Hi guys, welcome to the Chemistry Notes. Today we'll discuss the topic of chemical equilibrium. We will start with the irreversible reaction. Irreversible processes are those that only proceed in one direction. So we will show you example of the irreversible process. We will decompose ammonia dichromate. Let's write the formula of ammonia dichromate. And when you will supply some heat, you will expect formation of dichromium trioxide, water in the gaseous form, and nitrogen gas. So this process will be forward, so it will be only one-way process. Okay, so let's watch video. Here you can see small quantity of ammonia dichromate in the form of orange powder. As the heat source is applied, the ammonia dichromate starts to decompose vigorously. The decomposition is exothermic, producing visually stunning display. The intense color and volume of green smoke contribute to the visual appeal of the reaction. And here I want to ask you a question. The question, can you produce nitrogen dichromate powder from the ash? So let's draw the diagram. In the beginning we will have 100% of reactant, so 100% of ammonia dichromate, it will be here, and product will be at the level 0%. As soon as you will start reaction, you will expect that concentration of reactant will significantly decrease till it reach 0. So you will completely consume our reactant and transfer it to the form of product. And concentration of our product will increase at the same time till it will reach 100%. So we can draw here. Finally, we'll have 100% of dichromium trioxide, water and nitrogen, and 0% of ammonia dichromate, because all the ammonia dichromate will move to the form of the ash. Comparing irreversible process with a reversible reaction, you will find that reversible processes are those that can proceed in both forward and reverse directions. In the case of chemical reactions, it means that reactant can form product and product can form reactant at the same time. As example, here we will apply the reaction of copper to sulfate pentahydrate. Let's draw. 5H2O. If you will apply heat, you will expect that copper sulfate pentahydrate will decompose to the copper sulfate and water. However, if you will increase the concentration of water on the right side, on the side of the product, you will expect back reaction. So you will expect formation of copper sulfate pentahydrate again. This means reversible reaction. That reaction can move both forward and reverse directions. So let's watch the video. So let's take copper sulfate pentahydrate and transfer it to the evaporating dish. The heating place was set at 500 degrees. After you will transfer, you need to leave it to 1-2 minutes till you will reach required color. And during the heating, you need to stir using the spatula for even heating of the crystals. After 2 minutes, you will find that color will change to the white because of the formation of anhydrous copper sulfate. In order just to reverse the process, you need to turn off the heater and add some water. And in excess of water, you will expect formation of copper sulfate pentahydrate, which is blue. So color will change back to the blue. This experiment illustrates reversible decomposition, and you observed how blue copper sulfate pentahydrate moved to the form of white anhydrous copper sulfate, what I produce here, and reverse. So you forced white copper sulfate move to the form of blue copper sulfate pentahydrate. So this reaction can move both directions. And if we will draw a graph, we will find that initially we will have 100% of our reactant in the form of blue copper sulfate pentahydrate and no product, 0% of anhydrous copper sulfate. However, as soon as you will start the reaction, you will expect that concentration of reactants start to decrease and concentration of products start to increase. The difference between the reversible and irreversible process that at some point, so you will start your reaction, at some point product will start form reactant again, and the concentration of reactant will never reach zero. So it will not reach zero. And the same with the product. They will not reach 100%. So what's the point? If you will draw lines for the irreversible process, you will expect that concentration of the reactant will reach 100% and the concentration of the product will fall to 0%. However, for the reversible process, you will expect that at some point, so here it will be blue, at some point, white copper sulfate, anhydrous copper sulfate, will start to form copper sulfate pentahydrate again. So the reaction will move both directions. It can be 1% of the reactant and 99% of the product, but it will never reach zero, so it will not fall to the zero. At the same time, it can be, for example, 50% of the reactant and 50% of the product. It will depend on the type of the reaction, but we can affect this position of the equilibrium. And now we will discuss the factor that will affect equilibrium position.